Okay, now we're going to look at complex numbers. In our last lesson, we introduced the concept of imaginary numbers by telling you that the square root of -1 was equal to I. And that is exactly correct. And square root of -1 times the square root of -1 is equal to I squared. So therefore, I squared is equal to -1. And we will use that concept as we start working with the conjugates of these, okay? So, as we look at complex numbers is another number system. And it's bigger than all the real number system. Why? Because it has both the real numbers in it and the imaginary numbers in it. So a complex number is made up of two parts. The first part, A, is the real part, and the last part, I, is the imaginary part. So when you're combining these, you combine the real part with the real part, and you combine the imaginary part with the imaginary part. In other words, it is exactly what we've been doing, combining like terms. So let's look at doing this. So here's some examples of these. 1 plus 6i, -3 plus 2i, and 4 minus 3i. These are just examples of complex numbers, and notice the real part is always first, the imaginary part is always second. And it's not written correctly unless it's written that way, which is why when we wrote our answers from the quadratic formula, we wrote a fraction of the real plus the imaginary part. So that makes sense when you realize that that's the way complex numbers have to be written. And it's important to remember also that the square root of -1 is equal to I, and I squared is equal to -1, because we will use that when we start doing conjugates here. So let's look at examples for combining like terms. 2 plus 3i plus 6 plus 4i. Now, those parentheses are not grouping symbols like we would use for order of operations. They're just showing you this is one complex number added to another complex number. So all you have to do, if you like the stacking method, and some do, is just simply line these up. 2 plus 6 is 8. 3 plus 4 is 7i. That's all there is to it, is combining your like terms, just like we did in other like terms. Okay? Let's look at another one. 4 plus 2i plus 3 minus I plus -6 plus 3i. Okay, so let's look at the real part first. 4 plus 3 plus a -6 is the same as -6. So this is 7 minus 6 equals 1. So that's your real part. Now let's look at the other. 2i minus 1i, because if there's nothing in front, it's a 1. And then plus 3i. So 2i minus 1i is 1i. 1i plus 3i is 4i. Now write this in the right format. Remember the real part plus the imaginary part. And it is now finished. So now let's look at subtraction of these. And again, they're just like polynomial subtraction. We're going to use that -1 idea, distribute it to do your subtraction. So I have 6 plus 5i minus 3 plus 2i. So this is being subtracted from this. So let's put a 1 here and distribute it. So we have 6 plus 5i. -1 times 3 is -3. -1 times 2i is -2i. And notice I did the stacking method again. 6 minus 3 is 3. 5i minus 2i is plus 3i. Okay, let's look at one more subtraction. -9 plus 4i minus -9 plus 8i. Again, make this -1 and distribute it to everything inside. So I have -9 plus 4i. -1 times -9 is plus 9. And -1 times 8i is minus 8i. -9 plus 9 is 0. 4i minus 8i is a -4i. And you could have written it like that too. Okay, now we're going to look at multiplying complex numbers. We've been adding and subtracting. Now let's multiply these things. And let's start first with a monomial times a complex number. Okay? So I have 4i times 2 plus 3i. Again, this is just distribution. 4i times 2 is 4 times 2 is 8i, and 4i times 3i, 4 times 3 is 12, and I times I is I squared. Now remember, earlier we talked about I squared is equal to -1. So we're going to substitute that -1 in for I squared. 8i plus 12 times -1 makes this -12. Now that's the real part of my statement and the imaginary, so I have to change the order because my real has to be first, my imaginary has to be second. Okay, so now let's look at a binomial times a binomial. 3 plus 5i times 4 minus 2i. And again, we have to use this with the foiling concept. Okay? So 4 times 3 is 12. 3 times -2i is minus 6i. 5i times 4 is plus 20i. And 5i times -2i is minus 10i squared. The numbers multiply, the i's multiply. Now, 12, -6i plus 20i is plus 14i, and minus 10, I squared has to be replaced with that -1, so I have 12 plus 14i plus 10. 12 plus 10 is 22. 22 plus 14i. Okay, let's look at another one. 2 plus 3i times 1 minus 5i. Again, same thing. 2 times 1 is 2. 2 times negative 5i is minus 10i. 3 times 1 is plus 3i. 3 times negative 3i times negative 5i is negative 15i squared. Combine the like terms. 2 minus 7i, 10. Negative 10 plus 3 is negative 7. And minus 15 times I squared is negative 1. So 2 minus 7i, and then negative 15 times negative 1 is plus 15. So this is 17 minus 7i. Now, let's look at this one. 2 plus 5i times 2 minus 5i. And look what happens on this. This is real important. 2 times 2 is 4. 2 times negative 5i is minus 10i. 5 times 2i is plus 10i. And 5i times negative 5i is negative 25i squared. Look, negative 10i plus 10i is 0. So I have 4 minus 25 times 1, because I squared is negative 1, sorry. Negative times negative gives me 4 plus 25, which is 29. Notice it eliminated the imaginary part of this complex number. That's what conjugates do. Just like they eliminated the radical, they eliminate the imaginary. So when we go to division, which is next, we're going to use that conjugate to simplify these. So let's look at division of these. So, just like in your other 6 minus 2i, your conjugate is 6 plus 2i. Only difference is the sign. It's 9 plus 4i. Conjugate is 9 minus 4i. Again, the only difference is the sign between the two. And a conjugate of I is negative I. Okay? And just like in your division of radicals, we can't have an imaginary in the denominator. So therefore, we have to always eliminate it by multiplying by the conjugate. So now, let's look at how that happens. In general, you have a plus bi times a minus bi. A times a is a squared. A times negative bi is negative a bi. And a times positive is positive a bi. And then bi times negative bi is negative b squared, I squared. Okay? Notice, these disappear, leaving you with a squared minus b squared times I squared. And I squared is negative 1, so a squared times b squared times negative 1 gives you a squared plus b squared. So now let's look at examples of this. So, 6 plus 3i times 6 minus 3i is equal to 6 squared plus 3 squared. Remember, a squared plus b squared? A squared plus b squared. 3 is your b. So this is 36 plus 9, which equals 45. It makes it a lot easier to do these. So now let's look at 8 plus 9i over 5 plus 2i. Now you're going to have to multiply by the conjugate, which is 5 minus 2i and 5 minus 2i. Your denominator is going to be 5 squared plus 2 squared. This is going to be 40 minus 16i plus 45i, and then minus 18i squared. Okay, so my denominator is 25 plus 4, which is 29. Negative 16i plus 45i will be plus, my mind's shutting down, 29i, and 40 plus 18 is 58. Okay, now we can factor a 29 out of the top over 29. These 29s will cancel, leaving me with 2 plus I as your answer. Okay, now let's look at another one. 1 plus I over I. Remember, we said the conjugate of I is a negative I. So multiply by negative I. This is going to equal negative 1, because that'll be negative I squared, giving you a positive 1. And this is negative I minus I squared, which will give you, that'll be negative 1 plus, this will be 1. Or we'll just write it I, negative I, minus negative 1 over, well, we'll just put negative I squared. Negative times negative 1. So this becomes positive 1, so 1 minus I over 1, which leaves you with 1 minus I. And remember, that order is very, very important in these, okay? You have to have the real part before the imaginary part. Now let's look at some more problems. One over I. Again, your negative I is your conjugate, and this is going to give me negative I over negative I squared. So negative I over, this will be the negative of negative 1, gives you negative I over 1, which is negative I. So, what happens when we start looking at I to the 5th power, and I to the 9th power, and the 13th power, and the 10th power, and all these other powers? Well, we have a way of dealing with it. And what you're looking at is the exponent on your I. So there's 4 exponents that are really important. I to the 1st power is equal to the square root of negative 1. I to the 2nd power is equal to negative 1. I to the third power is equal to the negative of the square root of negative 1. And I to the fourth power, well, square root of negative 1 is I, so it's negative I. And I to the fourth power is equal to, in this case, 1. So, all we have to do is do a division on the exponent and see which one is the remainder. If we have a remainder of 1, our answer is the square root of negative 1. If you have a remainder of 2, your answer is negative 1. Remainder of 3, the answer is negative I. Remainder of 4, the answer is 1. Okay? So, looking for larger powers of I to the 24th. Well, this one is remainder 0. Remainder 3. Remainder 2. And remainder 1. So, take that, 24, and divide it by 4. Why 4? Because you have 4 possibilities. And this is equal to 6, and there's no remainder. Since there's no remainder, I to the 24th power is equal to 1. Because there's no remainder, therefore it's equal to 1. Okay, let's look at I to the 18th. Again, 18 divided by 4 gives you 4 times, which is 16. I'm going to do it this way, it's easier. 4, 16, remainder 2. What is the one that has a remainder 2? It is negative 1. So I to the 18th power is equal to negative 1. Okay, let's look at a couple more of these. I'll leave that up so you can look at it. And let's see what happens. Let's go to I to the 35th power. I to the 35th power. Well, 8 times 4 is equal to 32. 35 minus 32 gives you 3. Therefore, we have I cubed is the remainder when we have I to the 35th. So this is going to equal I cubed is negative I is your answer. And that is the last problem. Okay, that's the very last concept that you're learning in this course. Good luck as you try to finish up at this semester, and I wish you the best of luck as you're going into your final. And that's it. Bye-bye.